thank you all for coming tonight. I'm Lori Waller, President of the Friends of the Children's Eternal Rainforest. As many of you know, our organization supports the Children's Eternal Rainforest in Costa Rica. Right here in St. Louis and around the country, we work to energize children and adults to raise funds for the forest and to protect it. The forest can't protect itself, and it needs all of us to participate. This forest is the children's hope-filled legacy, and it's not only an international conservation effort, it is also a very important peace initiative, because children and adults from 44 countries around the world helped to save it. And now at 54,000 acres, in fact it's almost 55,000, the Children's Eternal Rainforest is the largest private reserve in all of Central America. And we're thrilled that you're here tonight to learn not only about this forest, but about the Amazon and about the importance of all rainforests for our future. We really appreciate that you're here to better understand the big conservation picture that we are all a part of. We're incredibly fortunate to have two of the greatest leaders in conservation here tonight, Dr. Peter Raven and Dr. Thomas Lovejoy. Peter will tell you a little bit about Tom, but I want to share just a little bit about Peter. As President Emeritus of the Missouri Botanical Garden, Peter takes great pride in the large expansion of the garden's programs around the world. This expansion took place during his 40 years as director of the garden and has been a major benefit to the people of St. Louis and far beyond. Peter is a champion of conservation worldwide, and Time magazine named him a hero of the planet. As a founding board member of the Friends of the Children's Eternal Rainforest, Peter has long been a passionate, very passionate voice for this project. Ladies and gentlemen, I give you St. Louis's own hero of the planet. Please join me in welcoming Dr. Peter Raven.
Thank you very much. We're absolutely delighted to have you all here this evening, and we welcome your support and your interest in our project. We're all used to hearing about how the rainforest as a whole is disappearing, and many of us know that more than half of all the kinds of plants, animals, and microorganisms in the world are restricted to the tropical lowland moist forest. And you know, when you hear that and you hear, well, Brazil, Indonesia, New Guinea, blah, blah, it's all disappearing, and then you say, well, what can you do about it? Well, the answer is you can do plenty about it by making more international our policies in the United States. We really do depend on virtually every country in the world, and we would be serving ourselves extremely well if we recognize that more explicitly. Now, more especially, rather than lamenting the demise of the rainforest, we here in St. Louis have a wonderful opportunity created by the passion of Rachel and Dwight Crandall, who came here to so their children could go to the Principia, and then Dwight became active in the St. Louis Science Center, and Rachel, a marvelously spiritual person, became involved with indigenous peoples and nature in Central America. And they focused on the work of the Monteverde Conservation League, which had begun some years earlier, Rachel and Dwight coming in contact with them then, and Monteverde itself and Costa Rica, the country. In 1949, the president of Costa Rica disbanded the military forces of Costa Rica after a rather bitterly fought revolution, tried to take over. At the same year, the first Quakers went to the village of Monteverde in the mountains, the Sierra de Tilarán in northern Costa Rica, and began organizing the community there as a dairy community. And by the way, in 1949, the Missouri Botanical Garden had its first botanical expedition to Costa Rica, because just before that, the Pan American Highway was extended over the Cerro de la Muerte down into Panama for the first time, and whole new areas were open to biological exploration. Here in St. Louis, as a result of that work and the interlocking of Rachel and Dwight's passion with the earlier founded Monteverde Conservation League, and the worldwide effort which began in 1986 to gather money from school children to save this rainforest in Costa Rica, the rainforest that we have now, 55,000 acres, about 3/4 the size of the city of St. Louis, was assembled. And that rainforest represents our very concrete effort here in St. Louis, our own rainforest, a rainforest where instead of just wringing our hands and talking about the fate of all these gorgeous plants and animals that have been flashing on the screen, we can actually do something about it, and we do actually do something about it, thanks to the support of many people in this room and to any of the rest of you who can consider helping us to get on with our job. The rainforest in northern Costa Rica, in this friendly, educated, medically advanced country which has always had strong relations with the United States, is a wonderful focus of our activity. Now, Tom Lovejoy, who's come to speak to us tonight, has been a friend of mine for, I guess, about 45 years or so. We both became awakened to the need for international conservation as the 60s rolled along, beginning with Rachel Carson and David Brower and other people's works on more national conservation. And we became impressed with the need for international conservation, and now the interdependency of the world is absolutely beyond doubt, widely accepted, and totally necessary. Now at present, Tom is University Professor of Environmental Science and Policy at George Mason University, and also Biodiversity Chair at the Heinz Center for Science, Economics, and the Environment. He has been for over 40 years recognized as an expert in tropical ecology, conservation, finance, and environmental policy. He was deeply involved with the origin of the concept debt for nature and the idea of swapping debt owed to the United States for preservation in the forests. And in one form or another, that's played out as a major conservation theme ever since. Tom actually coined the term biological diversity, which was later elided into the term biodiversity in 1987, and is used to express the whole web of life and all the organisms that exist on Earth. He's won the 2012 Blue Planet Prize, which is, in a sense, the major prize in conservation biology. He's been Chief Biodiversity Advisor to the World Bank. He's served for a number of years as Executive Vice President of the World Wildlife Fund, and originated the television program Nature in its first years. He has played several roles at the Smithsonian Institution, and he's been working in the Brazilian Amazon since before anybody knew it was there, except for the Brazilians probably knew it was there, but since many children in the United States can't find the United States on a world map, who knows? He has played a seminal role in introducing politicians and other influentials to the importance of tropical forest, and with his very original plan, which helped farmers clearing, which persuaded farmers clearing the Amazon to leave beside chunks of forest of different sizes, and then watching what happened to the plants and animals in them, he's created a model that serves us well in understanding the fate of tropical rainforests with all of their biological splendor throughout the world. Tom has been an enormously important contributor to the field. He's given selflessly of himself in introducing these problems and the opportunities with them to many people, and we're delighted and proud that he's here with us tonight, and we're delighted and proud with our own success in our own rainforest in Monteverde in Costa Rica. And again, we truly appreciate your support in that. It's a way of really doing something good for world sustainability. Thanks for coming, and I give you Tom Lovejoy.
So thank you so much for the opportunity to be here tonight, to be introduced by my very, very special friend and colleague, Peter Raven, and to celebrate the deep sort of involvement of the St. Louis community with the biology of our planet through the Missouri Botanical Garden and the St. Louis Zoo, where we're here tonight. Because we're really talking about the biological infrastructure of our planet and our well-being. And I'm going to do a 30-minute gallop through 500 years of Amazonian history, give you all some sense of the kinds of challenges that are involved in sort of managing and protecting and stewarding any great piece of the tropical rainforests, treasures of our planet, of which the Children's Eternal Rainforest is such an extraordinary example. So, here we go on 500 years, and we're going to talk about an era that started in 1541 when Francisco de Orellana became second in command to the half-brother of Francisco Pizarro, the Grand Conquistador of Peru. And Gonzalo Pizarro left in probably I guess it was about February 1541, when Orellana was probably just barely approaching 30, having been born in the hard-scrabble western city of Spain called Trujillo. And they went off up over the Andes and finally down into the Amazon in search of the illusion of cinnamon and gold. They took with them 220 soldiers in armor, really great in a hot, humid environment, 4,000 native porters, 2,000 pigs, hundreds of horses, and by the end of 1541, approaching Christmas, the number of soldiers left was 80. The pigs were gone. The indigenous sort of enslaved assistants were gone. The horses were mostly gone. And Gonzalo Pizarro sent Francisco Orellana to go on with 49 of the men to see whether there was actually any point in continuing this expedition. And every time Orellana and his men arrived at a new river, it was a bigger river, and finally at one point all the men mutinied, said, "We are not going to go back all the way to Quito," and they very democratically elected Francisco de Orellana, elected him as their leader. And maybe 3 years later, they arrived at the Atlantic. But in the course, in descending into the Amazon, they found this extraordinary paradise of biological diversity. and also extraordinary Amerindian populations with highly developed cultures, such as still exists in remote corners of Colombia. Just amazing cultures, highly developed, huge populations. And then about 3 years later, they arrived at the mouth of the Amazon, having lost almost nobody in the process, having thought they saw Amazon women, which led to the naming of the Amazon River, and also led to a reluctance to publish the accounts of the journey because they thought everybody had gone a little stark raving mad. So the accounts of Oriana's voyage, surely one of the great expeditions of all time, was actually never published until 1895. But today, and I would really encourage you to do it, there is the first accessible book which describes this extraordinary odyssey. It's called The River of Darkness. And you just go to, surprisingly, Amazon.com and you can find it. So the Amazon indigenous populations basically collapsed in response to the diseases that people from the Western Hemisphere had brought to them. And the whole thing sort of collapsed into a very quiet place for hundreds of years. It was a place which had occasionally discovery of important commodities, resources. Chocolate actually was one, which we celebrate tonight with these extraordinary chocolates. But perhaps the biggest of them all was rubber. And once Charles Goodyear had made the discovery, which his wife must have hated because he discovered it by stirring up sulfur and rubber on the kitchen stove, and some of it fell on the stove, and suddenly there was vulcanization. The entire world was hungry for rubber, and the only way to get it was to get it out of the Amazon. So at the same time that the rubber boom was thriving, and the people of Manaus would build great opera houses like that in the 1890s, the same year Sir Henry Wickham, who had an obsession to make his fortune and fame by producing some really important tropical commodity that everybody could use, Sir Henry Wickham actually managed to get rubber tree seeds out of the Amazon over to the Royal Botanic Gardens at Kew, which was then the world sort of center for economic botany, and that about 20, 30 years later led to the successful Malaysian rubber plantations, which didn't have the native diseases and pests that rubber had in the Amazon, and that led to the collapse of the great rubber boom. So he became Sir Henry Wickham. The Amazon went dark, and at the same time that Wickham had done all of that, in Sweden, the famous chemist Arrhenius published a paper in 1896 in which he sort of explained that the reason the Earth had a habitable temperature was because of the presence of greenhouse gases. It's interesting, it all sort of happened in that same decade. What Arrhenius didn't know, and we will get back to later, was the detailed history of the temperature and the climate of the Earth for the previous hundreds of thousands of years, and in particular that for the last 10,000 years, the Earth had an extraordinarily stable climate during which essentially all modern civilization emerged. So after the collapse of the rubber boom, all that remained of the Amazon was the occasional extraction of an important commodity like Brazil nuts. And basically every Brazil nut you have ever eaten was harvested from trees in the forest. It doesn't grow well in plantation because the pollinator needs a whole bunch of other trees to support it during the years that the Brazil nut is not in flower. And it was also a place which was wonderful for science. So back when I was a graduate student and ended up doing my thesis in the lower Amazon, and we built this first tower that would go up in the Amazon forest canopy, I basically shamed Tory Peterson into coming down. I said, "Roger, you have never been to the Amazon?" And of course he immediately had to go. And when he arrived and discovered there was this tower, he dropped all his plans, and every morning Roger would climb up the tower like at 5:30 to see what was going on in the forest canopy. And this is Tory Peterson, the world's most famous bird watcher, at 30 meters above the forest floor, seen from 35 meters in a view I've never ceased to call a bird's eye view of Tory Peterson. But other important things were being discovered by science in the canopy, how jungle yellow fever, which occurred in the canopy between howler monkeys and little blue mosquitoes, how did it get to people? Well, when you cut down the trees, the mosquitoes end up biting the woodcutters. And we learned some other things. So there's this extraordinary river system, literally as big as the 48 states, literally a tenth of the world's, 20% of the world's river water, with 3,000 species of fish, with these extraordinary bits of river chemistry. So here we're looking at the black waters of the Rio Negro coming together with the silt-laden white waters of the mainstream Amazon, and we're trying to look at all of that and understand it, and how did it support this incredible diversity of fish. So literally, 3/4 of the animal protein eaten by people in the Amazon is fish from those rivers. And when you really look at the water chemistry, you can't figure out that it should be able to support that productivity. Well, it turns out, as scientists looked at it, that when the rivers rise, 10 or 20 meters, not only can fishermen sort of canoe into the forest, but fish can swim into the forest. And there they feed on fruits and nuts and other organic matter that falls into the water. Piranhas go vegetarian and eat rubber tree seeds. And so in the end, you have this enormous transfer of nutrients from the terrestrial system to the aquatic one. So science was exploring that. It was also exploring what shattered the dogma that in any particular place, if you look at the vegetation, it's the consequence of the climate, and vegetation has no influence on the climate. Well, good Brazilian science proved that in fact the Amazon was making half of its own rainfall. The water was cycling as it moved from the Atlantic to the Andes, and if you looked at what happened in a particular place, literally 3/4 of the rainfall would return to the moving air mass moving to the west to become rain again. And of course we began to think, well, what happens if a lot of that forest is cut and the evaporative surfaces aren't there and the trees can't sort of do their evapotranspiration? So there was an early crude model that said that there would be a couple degrees of increase in temperature and big decrease in rainfall. And at the same time, people began to once again try and interact with the indigenous people, which had been so sort of collapsed by the impact of modern civilization. And at that time, people really had, a rather minimalist appreciation of what those peoples were like. And nothing sort of says it better than this World War II aviator's map, which divided the tribes of the Amazon basin into two kinds, hostile and unfriendly. So the next big era of change started in the 1980s as roads really began to be built. And this shows the first major highway built in the Amazon after the late 60s, early 70s, and was actually a well-designed World Bank project, which was poorly executed. We can tell you that story some other time, but you can see sort of huge deforestation following the roads. And suddenly we began to think, well, you know, that forest might not be there forever, and it might in fact go through a sequence such as we've seen in many parts of the world, in which a forest, here we're looking at Atlantic forest in Brazil in 1945, 1960, essentially 1990. I may read the number wrong, but the point is, as the forest is diminished, it's broken up into fragments. And so one of the other big questions that began to arrive is, you know, what does fragmenting a forest actually have to do with what can survive in that forest? And as Peter knows, that's been one of my specialties in biological investigation. And this is the giant experiment we set up to do it 34 years ago. And to give you a sense of what happens is in these forests, there are these extraordinary swarms of army ants, 500,000 or more, which go through a 3-week cycle, a part of which they advance across the rainforest floor, sort of attacking whatever they can get. And then there are a whole bunch of birds that follow the army ants and try and snatch some of the fleeing insects before the ants get to them. So the big question is, how big a piece of forest do you need to keep that going? And the answer in this particular case is at least 100 hectares, which would be multiply 2.5 to get the acres, because that can support just 3 colonies, and you just have to have one active on a particular day in order for the birds that follow them to support themselves and be able to raise their own progeny. So this is one of those fragments. We've discovered that they're really vulnerable to windfall. That does not look like a piece of forest, does it? I mean, it's really been hammered. And so you lose a lot of the just sheer biological mass of that forest. So that was a little piece of what was going on. And we also began to have serious fire. So this is fires detected by a satellite in 1987. Literally 2,500 fires in that same region where they were building the highways in first highway in western Amazonia. And in 1997, an El Nino year, which was particularly dry in the Amazon, literally there was a smoke cloud as big as Brazil hanging over South America. So serious issues here, more and more roads being built, and every time you build a road, things follow the road that were not particularly contemplated at the beginning. Now there are 3 highways planned from Brazil to the Pacific. One is almost complete. And that begins to be what the Amazon looks like, covered by a network of roads. Not good for the forest at all. And we've learned that it sort of proceeds in this kind of fishbone pattern, and that the closer you are to the road, the more likely it is there's going to be a fire problem. And now there's a new wave of gold exploitation. This is in Amazonia and Peru. It's really serious. I mean, they really just tear up the rivers in search of gold. And all the roads are coming together in ways that we really worry will lead to a tremendous amount of deforestation. And there's sort of a choice. We're looking at either follow the big infrastructure integration program for regional South America, which is what that IRSA means, or maybe we could design it differently so more of the forest could survive. And in fact, so that the forest could survive as a system. But in the meantime, there's all the exploration for oil and gas, forest contracts being issued in western Amazonia, big dam projects being funded by Brazil and other Amazonian countries because there's much more elevation there, you get more power generated, and not particularly well executed. And this is just the first of dozens that are currently being planned. They won't all happen, I'm sure of that, but one needs to know what's being planned. And there's even a plan to have a major power line from western Amazonia to southern Brazil, direct current, just as Westinghouse would have recommended. So one of the really interesting things about the Amazon is this issue of how the Amazon makes its own rainfall, which I referred to earlier. And nowadays you can actually look at models of how moisture is generated around the world. And what you see, if you look at the right, is that moisture comes off the tropical Atlantic and keeps being generated in the Amazon basin until finally it hits the high wall of the Andes. And then some of it gets deflected south. So it's important for the soybean growers in Mato Grosso. So this is one of the things that could actually change how government looks at all of this. But in the meantime, with the deforestation, we're beginning to see major droughts, historically unprecedented droughts. So there you have 2010, the most recent, and 2005, which raises the question, are we close to some tipping point where a whole chunk of the Amazon could actually reach a state where it would not be generating rain and it would essentially no longer be able to support rainforests? So it's a real question, and it's also tied in with climate change in a more complex sort of not a problem than I can describe here, but it's part of what leads one to the conclusion that the given goals for climate change, stopping the rising concentrations of greenhouse gases at 450 parts per million or 2 degrees is in fact too high for the biology of the planet. And it's also too high for sea level, because the last time the oceans, the planet was 2 degrees warmer than present, the oceans were 4 to 6 meters higher. I mean, what more do you need to know, right? It would be really bad for lots of coastal cities and national capitals like Washington, D.C. So, as we think about the Amazon and the rainforests of the world and the ecosystems of the world, one of the really interesting things is that we always hear about, the excess CO2 in the atmosphere from the burning of coal and gas and oil, and that's true, and it's an increasingly larger number, but there's also a big number about the destruction of ecosystems over the past 3 centuries, because they're all built of carbon too. So that's deforestation, degradation of grasslands, agricultural systems that leak carbon. And that gives us a really important way forward to deal with climate change, because it's basically an annual equation like this. And a whole bunch of CO2 goes in the atmosphere from burning fossil fuels. Another important piece comes from the destruction of tropical forests. Half goes into the atmosphere, a quarter into the land, a quarter into the oceans, and we can play with that equation. And the good news is that twice in the history of life on Earth, there have been screamingly high CO2 levels brought down to pre-industrial levels by natural processes. And a big piece of that is biological. A little bit of it is the weathering of rock into soil. The issue is we don't have tens of years to repeat that kind of process. But what we could do is be really active about regreening our planet, doing ecosystem restoration, doing the kinds of things that the Children's Eternal Rainforest represents all over the world, with forests, with grasslands, and with our agricultural systems. We can literally take half a degree or probably more of potential climate change out of our future. So this just shows where tropical forest remains today. This is a little calculation that Stuart Pym did about how much CO2 you could actually take back by ecosystem restoration. Numbers aren't particularly important to the point tonight, which is that we can make a huge difference doing that. And then there's tons of good news. It's not all the bad stuff that's going on with gold mining and highways and soybeans and all the rest. On the positive side of the ledger, there's been an extraordinary amount of conservation that's actually occurred in the Amazon basin. So when I arrived, there was one national forest and one demarcated indigenous area. By 2000, the Brazilian Amazon looked like this. By 2009, it looked like that. That's what it looked like in, I guess, around 2000 for the entire Amazon. And when you really add in all the indigenous areas, it's quite impressive. Now, it's not enough, but it gives one tremendous amount of hope. So, cities will be important in how we manage the future of the Amazon. And so in Amazonas state, most of the economic product is generated in the capital city of Manaus, and it has the lowest deforestation rate in any Amazon state. And so there are all kinds of things to do with local communities. We return to the indigenous people, empower them in their management of their own lands, because they have like a quarter of the Amazon is now essentially under title to them. They're learning how to use GPS systems, manage their own lands. It's quite extraordinary, right? The people that we thought were just hostile or unfriendly, right? And in the end, the richness is in fact in the biology of the Amazon. So this is the front end of a bushmaster, nasty viper, which causes its victims' blood pressure to go to 0 forever. And I can guarantee you there's a significant percentage of the people in this room tonight whose high blood pressure is under control from medicines that come back to studying that bit of biology. It's quite amazing. Whoever would have thought that would be the case? And perhaps one of the more amazing implications of Amazonian biology for human civilization, this is the giant Amazon water lily, and that's what it looks like on its underside, and that really impressed Joseph Paxton, who was the chief horticulturalist for the Duke of Devonshire, and led him to imagine that, in fact, one of those lily pads could support an enormous weight. And that, in turn, led him to design the Crystal Palace for the Great London Exhibition of 1851. He became Sir Joseph Paxton, and that led to half the buildings built in modern metal beam architecture in the industrialized world. So that is what the Amazon has to offer us in the future, because we've just scratched the surface. So thank you very much, and thank you especially to the Children's Eternal Rainforest, because you exemplify what this is all about. Thank you. So, I mean, seriously, I've been talking about the Amazon, this iconic big piece of rainforest in the world, and we're here to celebrate a much more modest piece of rainforest, which makes a huge difference in the world. It's got enormous leverage. First, just because it has been sort of acquired by the interest of children around the world, because it's in Costa Rica, a country which is always a leader, always visionary. And, you know, you've heard about it. It's 55,000 acres. It's magical. It's got 450 species of birds and 120 species of mammals. And it's almost St. Louis's own rainforest, right? I mean, the relationship between St. Louis and the children's eternal rainforest is a very special one.